Welcome to Lab 5, Part 2, Wildfire Risk Assessment. To begin, let's have a little recap of what you've done so far in this project and why. You started by downloading the most accurate LANDFIRE data. Then, you went through and analyzed the LANDFIRE data to see how it compared to actual conditions on the ground. You then took the changes that were discovered through that analysis and through communication with the manager, and you applied those changes across the landscape. With that corrected landscape layer, you produced fire behavior output and compared it to expected and observed fire behavior and effects, and you also compared the modeled fire growth to the observed fire growth. Now that you have a good solid background in what the landscape looks like and how it generally compares to measured fire behavior, we're going to start to produce some expected fire behavior under one set of environmental conditions. Here's an important fire and fuel modeling side note. You're about to justify the existence of a very large and expensive fuel reduction project based on the output of some fire behavior models. There's a lot to learn about fire and fuel modeling to make them the most effective, but that, sadly, is not the scope of this class. As we produce and analyze output in these labs, it's important to remember that all models are wrong, but some models are useful. There are many sources of error, including the error that we apply as inexperienced users. We will certainly be creating some potentially informative and useful output, but remember that the process of thinking about the inputs and interpreting the outputs is perhaps the most important outcome of these labs. We're going to begin this lab by using FlamMap 5. As I previously said, the scope of this class is not necessarily to really dive into these fire behavior modeling systems. I do want to make sure, however, that you are able to go from the beginning of this process to the end of it on your own, if you so choose to do this kind of analysis in the future, for either a final project for this class or for other projects outside of this class. I am asking you to at least attempt to create the inputs for these fire behavior runs, and if you encounter errors in creating the outputs, then please let me know. Your first step is going to be to set up your inputs folder. So in your Lesson 5 folder for this class, you'll create an inputs folder. You're going to navigate to where you have saved your LCP files in Lesson 4, and you're going to paste these LCP files into this inputs folder. We're going to be using these LCP files to create fire behavior outputs in FlamMap, and one of the steps that's important to perform there is to make sure that FlamMap knows what projection this LCP is in. To do that, there are some specific directions in the How to Use FlamMap guide, but to walk you through that process, you are going to navigate to where you have some LANDFIRE data. I am going to go to my Lesson 3 original LANDFIRE folder and just one of these LANDFIRE layers. In the US 140 folder, you will find a file called prj.adf, and you can copy that and navigate back to your Lesson 5 folder, Inputs, and you can paste that PRJ file here. So you'll name it the same name as the LCP file. So I'll name this one BBB WUI, and the suffix will be PRJ. Now, if on your system you're not able to see these suffixes, then there are some instructions again in that How to FlamMap guide about editing those suffixes. Now, those have the same name, so FlamMap will recognize that if you load this LCP file, this is the associated projection file. Now to FlamMap. So open up FlamMap. You might need to search for it. You can get to it through the ArcFuels toolbar. If you go to Tools, in the previous lab we did connect to some of these models. So you can connect to it that way if you previously connected it, or you can just open the program by itself. Either way, it opens up with a blank page, and you click on No Landscape File. And you'll navigate to your Inputs folder, and we're going to start with BBB corrected. So you should recognize this landscape pretty well now. And we are going to be performing our fire behavior analysis in a subset of this landscape. We downloaded this whole landscape so that we could have part of the rapid fire and our project area, but now we just need our project area. So we're going to go to analysis area and select new analysis area, and I'm going to drag this so that the east and south edges are in line with Payette Lake. So try and match this up as close to mine as you can. And I'm going to right click it and say create new analysis area. One thing that we will also do is add a theme to our area so that we can have some visual reference for where things are. So we'll go to themes, new vector theme, and we'll navigate to our lesson 3 data, not in the geodatabase. It's not going to be able to see the geodatabase, and add the BBB treatments. So now we'll be able to see where we are. And we're going to start a new run. So you can double click on runs, and we'll label this run NT for no treatment and FB for fire behavior. If we click on this little dot thing, we can navigate to our lesson 5, our lab 5 data, and locate the FMS file. And these are under high fire behavior conditions, so these are drier fuel moistures. If we click on this pencil icon, you can see the fuel moistures that we've selected. And these fuel moistures and the winds that we'll be using were collected using Fire Family Plus. So I downloaded the Ski Hill RAWS station data. I did include the Ski Hill RAWS station FW13 file if you are familiar with Fire Family Plus and want to explore that data. So I used the RAWS station information to figure out what values were reasonable for this area under more extreme wildfire conditions. Our wind speeds at 20 feet we'll set at 5 for now, and 290 for our azimuth, and we'll generate gridded winds. This takes the upper level wind direction and adjusts it for the topography. And then we'll change our full year moisture content to 90 and select apply. In the fire behavior outputs tab, we'll select fire line intensity, rate of spread, flame length, and crown fire activity. And we will be choosing Scott and Reinhardt, which has been shown to be a better representation of crown fire initiation when using LANDFIRE data inputs. And we'll apply that. And we'll go to minimum travel time, and we will press this 3 buttons here, and we'll select our west ignition shapefile. So I used the drip torch tool here in FlamMap, and I created an ignition along the west edge of our treatment units, purposefully to set fire through them to see if there is going to be a change in the type of fire that's observed in the different fuel treatment options. For our maximum simulation time, we want to model this fire over 4 days. If there are roughly 6 hours of burn period per day, that would be 360 minutes per day, and 360 times 4 is 1440 minutes to have this simulation burn for 4 days. Obviously there's a little bit of fudge factor there, but that's our estimate for now, and we'll keep that consistent between runs. Our spotting probability is 10%, so 0.1, and we're interested in arrival time grid, flow path, major path, and arrival time contours. And I'll just click apply, and then I can launch MTT. At this point, if you have other programs that are running on your computer, it might be good to close those out or save programs that you have open. Just make sure that FlamMap has the attention of your computer so that you can process this run a little faster. So that took my computer 40 seconds to run, and click close. So now you can see roughly where it expected this fire to move. Your fire spread may look different than mine. This is a variable analysis, so it'll look different, a little bit different each time that you run it, which is why doing multiple runs is so important. In this case, we are of course just having time to do one run comparison, but we are hoping to see some kind of an impact from the fuel treatments we apply even in the 1 runs that we're comparing. So now we're going to be generating some output for burn probability. So you're going to click on runs, and a new run will appear there. And we're going to name this NT and then BP, and we will use the same inputs. Navigate to my data folder, high winds of 5 miles per hour, degrees, 290, generate gridded winds, foliar moisture of 90, and apply. For burn probability, we're going to skip over the fire behavior outputs because we have already generated those, and we're going to go right to minimum travel time. And we're going to choose random for ignitions and use 2,000 ignitions. So what this is doing is saying that if we had 2,000 ignitions, not necessarily at the same time, but just different individual incidents, which areas would burn the most often. So those would have the highest burn probability. And we're going to do that for a burn period, so 360 minutes, and we will apply our spot probability of 0.1. And we're just looking for an output of burn probabilities. So again, this is a little bit more labor intensive for your computer than the first MMT, so make sure that those programs are saved. So we'll click Apply and then Launch MTT. So that took my computer about 2 minutes to run, and we will close this out. And to view the burn probability, we're going to double click or click on this magnifying glass, and that'll show you the burn probability across the landscape. So these redder areas, if you double click on burn probability, you'll see the attributes. The redder areas have a higher probability of burning more frequently than the gray areas. So for your lab question, you're asked to take a screen capture of your outputs and your inputs. So I'm going to just minimize some things here. You click these minus buttons. And I'm going to open up both my fire behavior and my burn probability. And if I double click on this again, it's just going to open up the same input window that I had entered. And clicking on the pencil tool, I can expand my fuel moisture file and drag that to the side, and then take a screen capture of my whole project. The layers that are on in the background aren't as relevant, but if you do want to display those, you can double click on these check marks or X's and they'll turn on and off. Your themes here are where your fuel model layers are. So if you wanted to turn fuel model back on, you'd open that up and click on fuel model. So now we're going to be exporting this information so that we can import it into ArcMap. We don't need all of these files. A lot of these files were generated by default, so there's only some that we need. We're going to start up here with the flow paths, so we'll right click on flow paths, select Save As, and you're going to navigate to your Outputs folder. And we're going to create a naming scheme where we have no treatment and then underscore, and this is going to be FP for flow path, and select Save. And then continue on with each one of these important layers. So we'll do major paths, MP, and we don't need our arrival contours. We are interested though in our flame lengths, NT, FL, and rate of spread, NT, ROS, fireland intensity, and ground fire activity. And we are also interested in arrival time, MTT arrival time. For From our burn probability, we are only interested in the burn probability layer. So now we have all of the layers for the no treatment alternative. If you wish to save this FlamMap project, you can do so. If you feel like you might use it for a different exercise, you might mess with the variables a little bit more. Either way, you'll need to open up a new FlamMap project, and this time you will load the roads LCP. If you are relying on these demos to walk you through these steps, you can just rewind and do the same steps but with the roads layer and then the urban interface layer. And so you'll be narrowing down your processing area so that you don't have to spend so much time in processing, adding the theme, creating your fire behavior output and your burn probability output, and then exporting those layers so that we can import them into ARC. So now we're going to open up a new ArcMap project, and we're first going to add a layer of our project into this program so that we can have some spatial reference for where we are. So I will navigate to the lesson 3 data, and I will add treatments. Now I'm going to be batch converting the ASCII files that were created in FlamMap to rasters so that we can access their attributes tables and change how we are viewing them. So we'll go to Tools, Batch Convert ASCII to Raster, and navigate to our Outputs folder. And so you can just click on the Outputs folder and then click OK. And we're going to start off with the Crown Fire activity layers, since those are going to be a little different. So selecting each of those, pulling them over, and because we added this shapefile, we have a spatial reference for our project. And for our target folder, we're going to be choosing the inputs folder for Lab 5, mostly so that we reduce a little bit of the noise in the outputs folder. It gets a little messy in there when you have ASCII files and rasters in the same place. So we'll put those in our inputs folder and click OK. And select Convert. Now we're going to slide the rest over into our files to be converted. This part is very important. You need to select for data type floating point, which is going to allow the values for each of these layers to be different than a whole number. Some of these values will likely be smaller than a whole number, and so we need to make sure we account for that in the floating point data type. And those will also be saved in our inputs folder. Click Convert. Those were successful. Close this out. And now I'm going to take a moment to organize my data. I'm going to make several new group layers and minimize my conversion results and slide these into place. And now we will also add our shape files that we created in that analysis. So in the outputs folder, adding these shape files for flow paths and major flow paths, and then sorting those into the proper folders. Now we're going to move on to the next part of this lab, which is to create several visual displays of the fire behavior output so that we can present that to our managers and decide whether or not we want to present that to our project stakeholders. We're now going to work on displaying several of these outputs together so that we can create a usable figure. We'll start with burn probability. I'm going to turn all my other layers off and turn burn probability on and expand this out for each of these categories. Now we need to look at our burn probability layers and figure out which one has the broadest distribution. If we just compare these as they are, the values or the colors wouldn't quite be comparable because they're spanning a different range of numbers. So we need to stretch each of the burn probability layers to the broadest range of values, and that is, for me, the roads layer. So I'm going to simply adjust the symbology first of the roads layer. I'm going to left click on this color ramp and select the red to blue option, and I'm going to choose invert so that the red colors indicate higher burn probability. So here's my burn probability for the roads layer. Now I'm going to go to my WUI layer, right click on it, select properties, and choose from a type down here. So I'm on the symbology tab under stretched, and the type is going to be minimum maximum. I'm going to check this box for edit high low values and change this to 2, 1. And then in my color ramp, select red to blue and check the box for invert. Now I have my WUI burn probability and my roads burn probability. And then going down to no treatment, I'll do the same thing, right click on it, select properties, minimum maximum, and change the color ramp, and select invert. So now I have burn probabilities for each treatment type. Next we want to make a figure that shows each of these 3 treatment types in on one page. We're going to create some new data frames, so go to Insert, Data Frame, and I'm going to minimize all these things here, and I'm going to do that one more time. And so I'll go again to Insert Data Frame. Now I'm going to have 3 data frames. I'll label this one No Treatment, this one Roads, and WUI. And I'm going to take the data from this first data frame and drag it down. Notice it doesn't remove it from the original data frame, it just adds to it. I'm also going to add treatment polygons from lesson 4. So I'm going to go to my lesson 4 folder, outputs, and choose roads and WUI treatments. This is going to serve as an important visual reference for our project. And I'll drag those to the right folder. I'm just going to remove that from here. And I need to change the symbology on these. I'm going to change them to hollow and a width of 2. Okay. And now I'm going to be working in the Layout tab. So I'm going to click this Layout view down here. And I'll expand each of these just so I need to turn on my burn probability layers for each one. So to begin with, all my data frames are kind of piled up on each other, but there are 3 distinct black boundaries here, and I need to organize them on my page. Your layout view may be in portrait, mine's in landscape. To change that, you can go to File, Page and Print Setup, and select landscape. The organization that you choose is up to you based on what you feel is going to best represent your data. So navigating in the Layouts tab, you see that this toolbar has been activated. This is the layout navigation, and to best demonstrate how this works, we'll use the pan function. So if I can use pan and move around in the layout page, Or if I pan with the Tools toolbar, it actually drags around the image there. And it looks like I want to zoom in this one a little bit, which is I can do from here as well. I'll zoom in one more notch. And I should also add the BBB treatment perimeter, just so that's in each of those, so you can see where they are in reference to each other. So I'm going to go to my lesson 3 data, and add project boundary. And I'll add that to each of these layers and change the symbology. So now I want to make each of these data frames the same size. So I'm going to stack them on top of each other and drag this box so that it's the same size as the previous. I'm going to take the time to get one data frame centered just how I would like it, and then I'll be able to copy the other one. So I'm going to use the pan function here, drag this down a little bit so it's showing the area all around the treatment, and this is right in the center. And since I have the pan tool activated, I'm not going to be able to do other things right now, so I need to click on this select element icon, and now I can right click, or click first so it activates it, right click on a new layer and select properties, and for data frame extent I'm going to choose the same extent as another data layer, and I believe this data layer is, yep, that's no treatment. So I highlighted it and then it showed this one bold, so this is the no treatments layer that I already have set up. So I'm going to right click again, properties, and other data frame, and select no treatment, and OK. And so now it's zoomed it to the same extent, so these are going to be really comparable. And I'll do the same thing for my last data frame. Now I can organize these on the page. So it might make sense to have no treatment on the bottom and these two on the top, just as your preference on how you want to organize them. So now we'll add some of our map elements. I'm going to go to Insert, and I can start with the title, and I will call this BBB Burn Probability. And I'm going to have my title down here. And if I want to adjust this at all, I can double click on it, and notice you can't type in a different font there. You have to select change symbol, and then you can change the font size. Make it bold. And now I'm going to insert text boxes, and this text box is going to be the label for each of the treatments. So I will click if I click off it, then click back onto it, I'm able to open this dialog box, and I will type no treatment. And I also need to change the symbol here. And then I can copy and paste that, and I think the bottom will be a better place for this. And this one is the WUI treatment, and this one is roads treatment. Now we'll add our legend. So it's going to add, when automatically selecting the legend elements, it selects it from the active layer. So you can see it's selecting from the roads layer. So we're going to keep the project boundary and roads treatment and burn probability because it's going to be the same for each of them, even though it's only pulling them from one data frame. And right now we'll just go ahead and create it. We can adjust it later. So the legend reflects any information that's over here. So if I want to just call this treatment, because it's going to be referring to either the roads treatment or the WUI treatment, I'm going to take out the word road, capitalize treatments, and edit this as well, just so that it looks a little bit better. And then if I expand my burn probability, I'm going to take out this value, and I'm even going to delete the title of this so that it is a little bit cleaner in my legend. And then insert again, north arrow, pick something that's not too gaudy. Insert scale bar. It's important that the scale bar has even value, so if it's like 3.5 or something, you'll want to shrink this down, but right now I'm happy with this distribution. You can edit that by double-clicking on it, and you can change the number of divisions or where the markers are. And now we need to add one more text box. In this text box, we will include some information about the figure. So, corrected LANDFIRE data in FlamMap 5. So then anyone that's reading this can know where this data came from. I'm going to double click on that again. I need to make 2 lines here, since it doesn't automatically text wrap. And now you will take some time again to organize. So as I was looking at this comparison, I thought that these roads treatment areas looked awfully high in burn probability compared to the others, and so I did do another run in FlamMap. And although I did see some changes in the burn probability, it looked like it had a pretty similar distribution. So again, each of you is going to see slightly, perhaps quite a lot different images for each of these burn probabilities, but as a class, we'll start to develop about 25 different runs for each of these, and so we should see some consistent patterns as we look at the burn probabilities across everyone's project. I've included an optional step where you can subtract burn probabilities from each other to see the change between these different treatment types. For the purposes of this lab, I am not requiring that. Once we've gotten it to a place where we like how it looks, we'll go to File and Export Map. And then you can save it to your Lesson 5 folder as a JPEG, and then that will be what you use as your deliverable for that question. And now would be a good time to save our project. So now we're going to go back to the data view, and we're going to start working with our flame length layers. So I'm going to minimize my burn probability, and I'm going to go, I might add this title back in here so I don't forget what it is. So now I'm going to adjust my flame length values so that they can have more obvious visual breaks that we can compare. I'm going to right click on my flame length layer and select Properties, and under Symbology select Classified, and I'm going to select Classify here, and I'm going to change my classes to 4 and my breakpoint values to 4, 8, 11, and then leave the last one as it is, and then click OK. And I'll change my color ramp to a yellow to red, and select OK, and now I can see my flame length distributions. So go ahead and do this for each of the other flame length layers. Once you have that complete, you can go back to your Layout tab, and I will just want to make sure that in each of these data frame windows I have my flame length selected, and you have all of the formatting already completed, the labeling's already done, and you have this new display for flame length. So I just need to change some of my title information. And notice when I double click on that, it comes up without the text, but I can just enter that text here. And I can change the information here as well. And I probably should have added something here about the conditions in which these were run. Something to describe how these were generated. And we'll need to adjust our legend. Double click on the legend. Because burn probability is off, so we need to go to add flame length. So do RFL here and add that over. And we'll subtract our burn probability from our legend. And it looks like it's actually pulling it from the roads. And even these values here you can adjust. That looks much better. And when you're done, File, Export Map, and then save it for your submission. Now we're going to go back to our data view for our rate of spread layer. So we'll want to change the color ramp of this to be a little bit more descriptive. So you can apply that same change to each of your layers. And then back to the layout view. We need to turn our rate of spread on. And then, as you did before, adjust the names, adjust the legend, and edit the description and the title. And once you're done, then you can export that map and move on to the next, which will be Crown Fire Activity. Crown Fire Activity has these 3 or 4 different classes. When we look at the FlamMap help guide, we can see that 0 is no fire activity, 1 is surface fire, and then 2 passive or torching, 3 is active. So we're going to change the symbology of our Crown Fire layer to reflect those colors and values. So the color here will be green, this will be yellow, orange, and red, and the value will be unburned, and click OK. Turn this on. Looks like I need to activate the roads layer. And now I can see the distribution of that fire behavior. Again, you can see that there is no Crown Fire activity in our treated units, which is good to show. So we'll do that same change to the other layers. Because I want to make sure I get the right colors and names for each of these layers, I want to import that. But in order to do that, they need to be in the same data frame. I'm just going to take a second to move my Crown Fire activity into another data frame as well, which means that then when I open Properties and select this folder icon, I can select the roads Crown Fire activity as the layer symbol. I could also have saved my roads layer as a layer, navigated to it, but this I think is a little faster. So I'm going to remove the roads layer from WUI and do the same thing up to no treatment. So I can see all my treatments there and adjust my legend and my title and description again. So now back in the data view, we will do the same thing for our fireline intensity layer. And this one we're not going to classify into categories, we're just going to apply a new color ramp to it. So I will choose a red to green, and I need to invert it. So this will show where the higher fire land intensities are in our area. So turning those on for each of those layers. And again, looking at that in the layout view, changing the title and symbology and exporting that map. Now we're going to do our final comparison, which is a visual comparison of the arrival time and flow paths. I think the best layer for now to have in the background will be our flame length layer. I'll re-add the title of this. And displaying the arrival time and the major flow paths. The flow paths themselves make it look a little too busy. So we will adjust how our arrival time looks by choosing a color ramp. I'm going to choose this purple color ramp and invert it and apply that change to each of the layers. And now to the layout view, and I'll need to work to make each of these look about the same. And it looks like I didn't invert the roads treatment, so I need to go back to this one, select invert, and then edit my legend. Oops, turn my select features on and take off. And instead of deleting this information, we want to adjust it. So this is pulling from the roads layer, so we're going to change this title to arrival time. And this one to major flow path. And I'm going to use my hand button to drag that around a little bit. And zoom out so I can see just slight variations in the flow paths. It also looks like I have different colors for my major flow paths, so I'm going to adjust those to be all the same color. Now it'd also be a good idea to add our shapefile for where the ignition started. So I'm going to go to my add data, and this is in your Lab 5 data, west ignition shapefile, and add that to each of the frames. And you can see that it just was added to our legend as well. And turn back on my select elements cursor, and now I can change my title and my description. In the description, it would be good to include that this output was produced under 5-mile-an-hour winds from 290 degrees as an azimuth. This is our final output that you'll be submitting for this lab. The final question is discussing how this output looks and doing some interpretation. And as you look through each of these JPEGs that you've created, try and see if there were any larger scale impacts from the different field treatments compared to the no treatment. And output like this is often what's used to justify the existence or the continuation or the increase of these types of field treatments. And so it's important to try and see if we are able to see any kind of impact from these. If we don't see an impact from these treatments, it doesn't mean that one doesn't exist. It just means that in our data we didn't see the evidence of impact. Now, between all of the different students that are running this, we'll see some slight variations between their outputs, so we might start to see some overall patterns. But if we do not, then we would go back and adjust some of our input weather conditions and our fuel model conditions maybe, and see if we can understand what circumstances would these field treatments have an impact on the potential fire behavior.